Right, moving our character around. This will be pretty straightforward. So let's have a look. What we'll do is we will just get rid of this drawString in the GUI, and not only that, we will make sure that we scale our object to its proper size and stick in 0f under the rotation, like so. So if I draw this, it's going to be facing up. Now let's say we want this object to move left, right, up and down. Well, in order to do this, we need to store the position of the object, and then we can change it. So we're going to create a vector2 variable. Vector2 position, I'm going to call it, or pos. And I'm going to say that equals a new vector2, and I'm going to set it equal to 200, 200, just to start off with. And then down here, when we draw our image, instead of saying a new vector2, I'm going to just enter pos. And of course we've set pos to 200, 200, so it will draw the boat at the position 200, 200. Then in the update, I'm just going to specify that if keyboard.isKeyDown keys.left pos. Now because it's a vector2, it has an x and a y, so we do dot x minus minus, and that will just take 1 off pos.x. And if keyboard.isKeyDown keys.right pos.x plus plus. I'll let you work out the y yourself. So if I run the code now, if I press left, the object will move left. If I press right, it will move right. Very good, eh? Not bad. Let's say though we have it that if you are let me think about this. Let's say we have it that if boost is enabled, then you can do it. So we could have a variable called boost. So we'll have a bool boost equals false. And then under the keyboard input, I'm going to state that this is if not boost, or otherwise if boost is set to false. And we're just going to annotate that. We're just going to say that if not boost, so if boost equals false, then run that code. Else, this means if boost is true, let's say we're going to minus off 4 and we're going to add on 4 like so. So now I'm not boosting, I'm not doing nothing. In fact, let's create a variable that toddles boost on or off. So if keyboard.isKeyDown keys.space, and this is where we need to make sure that the last keyboard state does not equal being pressed. So if last, so if L keyboard dot is key up, oops, is key up, keys dot space, then what we're going to say is we're going to say that boost equals not boost, and that will basically flip the boost variable. So if boost is true, it will equal not true, which is false, and if boost is false, it will equal not false, which is true. So now I can test this out. Moving left, moving right, press spacebar, move left, move right a lot faster. And in fact what we'll do is we'll just say that when we're drawing it, if not boost, draw it like that, else we'll copy it and we will draw it dot green if you're boosting. So a bit of a visual clue. Very fast, not boosting, boosting, not boosting, and so on and so forth. Now you can imagine though, let's say we have a lot of variables. We have a boost variable, we have a rotation variable, we have a speed variable. It gets quite confusing, especially if we have 30 boats, because we'd have pos 1, boost 1, pos 2, boost 2, acceleration 2, rotation 2, and so on and so forth. And this is where we're going to look at a simple structure to hold our position and our boost, right? So a simple structure that will hold both of them under one variable. And to do that, we need to define ourselves a structure. Now we can do it inside the game1 class, but I'm going to do it outside it, and I'm going to type in it that it's public because it wants to be accessible everywhere. It's a struct, and I'm going to call it, let's say, a boat struct because it is for the boat, and we do as open and close squarely brackets. And then I'm going to say another public because we need to be able to access it. So a public vector2 position and a public boost boost. Now with a structure you cannot initialize them, so I couldn't say equals false like so. I don't think I can anyway. No, I can't. It comes up with an error. So you cannot initialize variables within a boat structure, within a structure. So now what I'm going to do is I'm going to delete these variables are created here, and instead I'm going to replace it with a new variable, which is the one we have just created. This structure is in effect a variable. So we have boat structure, which is what we've just made. I'm going to call it boat1, like so. Now, what we can do is we can say in the initialize, because this is where we're going to initialize as variables, boat1 dot boost equals false. Boat1, and you see the dot allows us to access the variables inside our structure. So boat1 dot position equals a new vector2 200 200, like so. And of course I finished that off and I've just spelt false wrong, like so. And then what we have is we've just got to change these to boat1 dot boost, boat1 dot position, and same here, and same here. Boat1, in fact I'm going to copy this so it's faster. And there we go. And these down here finally. Oops, daisy. And here now it will work using a structure. Now structures are advantageous, they keep code simpler, it's easier to understand, because now if I was to, I could create another boat. I could go boat structure boat2, and then I could go boat2 dot boost is false, boat2 dot position equals such and such. So it allows you to group variables together within one structure, which makes coding a lot easier to understand and read, and also a lot easier to program without getting yourself confused. Now we can do one more thing with a structure. We can create a constructor, and this allows us to set variables when we create it. So what I'm going to do is I'm going to say that a public structure, a public boat structure. Now this is the same name as we have given to our structure, and then we do an open bracket, and I'm going to say, let's say it requires a vector2 new position and a bool boost state. So basically when we create this object we are going to give it the option of passing in a new position and a boost state. So what I'm doing is I'm saying position is going to equal the new position and boost is going to equal the boost state. And then instead of going boat1 dot boost and boat1 dot position, I can say boat1 equals a new boat structure. And then what it's going to do is it's going to come up and find this, because this is our new instance of our structure. And I'm going to enter as it asks. Let's have it just 1 second. It asks for a vector2, so I'm going to say a new vector2 at 300 300 and false. So what happens is when we run this code it finds our constructor, and our constructor is the same. When we create a constructor we make sure it's the same name of our actual, in this case, structure, which is boat struct. Then when we built this we said we want to have a vector2 and a boolean. So what happens is, let's look at where we've initialized it. What we're saying is, what we're saying is we're going to give it the vector2 300, 300 and false. So when this line here runs, this gets set to, new pos gets set to 300, 300, boost set gets set to false, and then it runs the code inside the brackets. So position equals new position, which in this case is 300, 300, and boost equals boost state, which in this case equals false. And then if I run the code, you'll see we have it all working lovely. And I can press that and go into boost state. Now, that is what a structure is. And it may have confused you a little bit with this added thing, but the more you get used to programming like this, the better it is for you. And the next chapter we're going to have a look at is, I think, classes.